The probability of an event. So the probability of an event is the measure of the likelihood or chance that an event will occur. So if you're rolling a six-sided die, you would want to find, well, what's the chance that when I roll that die, I could get a 2? When you're talking about probability, it ranges on a scale. If it is impossible, the probability of that event happening is absolutely 0. It can never happen. So on a six-sided die, the probability of rolling a 9 would be 0 because there's no 9 on that die. On the other side, we have certain, which is 1 or 100%. So if I asked what's the probability of rolling a number on a standard six-sided die, well, that's 100% because they're all numbers. Whatever you roll, you're going to get a number. In the middle, equally likely, 50%. And then to the left of that, we have unlikely, which is about 25%. And to the right of that, we have likely, which is roughly 75%. Now, theoretical probability is when all of the outcomes are equally likely to occur. And the way we find theoretical probability is we take the number of favorable outcomes, meaning what you want to happen, over the total number of outcomes. So let's say I said, what's the probability of rolling a 2? Well, on the die, there's 1, 2 out of 6 numbers. So the probability of rolling a 2 would be 1/6. Example 2, finding a theoretical probability. So it says you flip a coin and you roll a six-sided die. What is the probability that the coin shows tails and the die shows 4? Well, first of all, if I want to find this, I have to find the sample space so that I know how many total outcomes there are. So we're going to start the way we did before, and we're going to make our sample space with our tree diagram. So I'm going to start with my coin, and on my coin, I could roll a head, or I could roll a tail, or flip a head or a tail. Then after that, I'm going to roll my six-sided die. Well, if I get a head, and then I do my die, I could get a 1, a 2, a 3, a 4, a 5, or a 6. Or I could get a tail with a 1, a 2, a 3, a 4, a 5, or a 6. Now, if we list our sample space, we're going to have a head with a 1, a head with a 2, a head with a 3, a head with a 4, head with a 5, a head with a 6, or we could do a tail with a 1, a tail with a 2, a tail with a 3, a tail with a 4, a tail with a 5, or a tail with a 6. That gives us a total, if we count them up, of 12 total outcomes. There are 12 different things that could happen when we do this probability experiment. And we want to know the probability that the coin shows a tail and the die shows a 4. Well, that would be right there. And if I keep looking, that is the only one with a tail and a 4, which means my probability would be 1 out of 12. Now, when you write a probability, you can write it as a fraction, a decimal, or a percent. So if we write that as a decimal, it is approximately 0.0833. And if we convert that into a percent, that's roughly 8.3%. So if you have an 8.3% of this happening, I'd probably say it's unlikely, meaning it's probably not going to happen.